So today I'll be telling you about the intervention. Now, the first thing which we are going to do is to focus the area of interest properly. Now, while focusing the probe, maybe in this position I'm able to get the area of interest properly. This is a transverse position of the probe, or maybe sometimes in longitudinal position we are able to get the area of interest properly, or maybe sometimes in oblique position. Now, whichever position we are able to get a good view of the area of interest, we use that position. Now, when we have got a good view, let us see what is the probe position. Now, for example, we have got a good view and the probe position is this, like this, transverse. Now, we have to then see whether the probe is angulated or it is straight. Now, in this position, you can make out that the probe is tilted upwards. So the fact that the probe is tilted upwards, we have got a good position of the area of interest, but the probe is tilted upwards. What does it mean? That the actual area is not beneath the probe, but a little bit upwards. So as we move upwards like this, we'll find that the area of interest is still there in the view, and the probe will gradually need to be straightened. And once we move upwards further, the probe is now exactly straight. Now, this is a position which is important. The fact that the probe is not angulated, it may be transverse, it may be oblique, it may be longitudinal, but the fact is that it is not angulated means that the area of interest is beneath the probe. So beneath the probe, so if we put the probe straight, we are able to get the area of interest beneath it. When we were putting the probe here, the probe was angulated, which means the area of interest is upwards to it, because the beam is going upwards, and then only we are able to see the area of interest. So here, when the probe is without angulation, it means that the area of interest is beneath it. Now suppose the probe was longitudinal and we were able to get the area of interest. Now here the probe is longitudinal without any angulation, means that the area of interest is beneath the probe right now. Here the probe is oblique and we are able to get the area of interest. Again, it means that it is beneath the probe because there is no angulation. Now if there was angulation like this, it means the area of interest is a little bit away from it towards the side of angulation. So as we move more towards this side, the area of interest is still in the view, but now we find as we get the area of interest beneath the probe, the angulation will disappear. And finally, when we are keeping the probe straight without angulation, it means that the area of interest is beneath the probe. Okay, so we have to understand this part. Now, once we have localized the mass, for example, the mass is here, we have kept the probe a little bit oblique right now, but without any angulation, and the mass is beneath the probe, because we are getting a good view on the screen of the mass, and we can see this is the position of the probe. What does it mean? That the mass is beneath the probe. Now we want to go for intervention. So what we can do right now, just draw an imaginary line to in line with the probe position. For example, probe is going this way, so a line straight like this can be drawn. This is what I have done. You can make out better. So this is the line we have drawn in line with the axis of the probe. So we draw a line in line with the axis of the probe like this, straight, yes, and then we use a needle, and the needle is put along this line beneath, and we are going to go beneath the probe because the mass is beneath the probe. So we are going along this line and beneath the probe. So this is how we are going to move the needle. So needle is going to go like this, in line with the axis of the probe. Now this type of interventional technique is known as in plane focus, or you can say inline focus. It is along the line, and for the newcomers, the first and the basic way to go for intervention is this technique only. Why? Because in this technique you can see the full length of needle. Now I'll show you through an ultrasound picture also how it appears, the view appears. If you see to the ultrasound picture, you can make out here that the needle is seen in good amount of length. You can see the full, not only the tip of the needle, but you can see the shaft. A larger part of the needle can be seen going obliquely into this vessel. And this is the schematic diagram where you could make out that the probe was like this, and in line with the probe the needle was pushed towards the area of interest, which is this vessel. Okay, now suppose the probe is kept in a particular way and the needle is moved perpendicular to it. Then what will happen? The beam will cut the needle at right angle and you won't be able to see the full length of the needle as you were seeing in the previous picture, and you will only see the needle as a dot. Now this type of technique is known as out of the line, or you can say out of the plane focus. So that was in line with the axis of the probe. That previous one was this way, it was in line with the axis of the probe. So the needle was pushed in line with the axis of the probe and we were able to see the full length of the needle. Here what is there, that the needle is at right angle to the axis of the probe. So we are only going to see the tip of the needle. Now the problem in this case is that seeing the tip is, number one, difficult to locate many times rather than seeing the full length of the needle. And the other thing is there are reverberation artifacts which you can make out here. So you may not be able to make out the exact position of the tip, and sometimes you may think the tip is here, sometimes you may see the think that the tip is here. Further, what may happen, that the beam may not only cut the tip, sometimes it may cut even the mid part of the needle, sometimes it may cut the base of the needle. So you may not be exactly knowing whether this is the tip only, or this is mid part of the needle, or this is the base of the needle. So penetration may be more than what is required. Now I'll show you with a mannequin as well. Okay. Now suppose we move the needle like this, perpendicular to the axis of the probe. Now this, as I told you, is out of the line, or you can say out of the plane, and here we don't need to put the probe straight, and even angulation is fine, and we are angulating the probe upwards and the needle is moved like this towards the mass. We know that the mass is not directly beneath the probe because the probe is angulated and the needle is here and the needle is being moved towards the mass. And here you can make out that only the tip will be seen because the beam is going to cut the needle at right angle, and we may see the tip, or we may see sometimes the mid part or the base. but we are going to see it as a dot. Now this out of the plane or out of the line intervention is something which is tried by more experts, and I'm going to take this thing in the next part. This is a mass is occupying whole of the region beneath the probe. It is in the mid part, it is occupying the peripheries as well, and same applies for this vessel which is running throughout the part beneath the probe, in the center as well as at the peripheries. Now, when you are going to put the needle in any one of these areas, it is relatively going to be simple, because when the needle enters beneath the probe, it is going to hit this area or this area much more easily. Whether it enters from this area or whether it enters from this area, it is going to hit the area of interest much more easily. But when the mass is smaller, for example, in this case, you can see that right now the mass is focused in such a way that it is beneath the center of the probe. Here you can see the mass is just beneath the right side of the probe. You know that this is the right side, this is the left side as per the conventions. So this is beneath the right side. Here you can see it is beneath the left side. Now, if we are, suppose the probe is kept like this, and we are advancing the needle from this side, and this side is the right side of the probe. Now this is the right side of the patient and the right side of the probe is here, and we are going to put the needle from this side. And if we are putting the needle from this side and this is how the mass is focused, which means it is more toward the left side, then in that case we have to travel a lot. The needle has to move a lot before it reaches the mass. So this position where the mass is more towards the right side will be much more easier to hit. We don't have to traverse the needle a lot. Now, if the mass is towards this side, what does it mean? It is beneath this part of the probe, beneath this portion of the probe. In order to get it towards this area, beneath the right side of the probe, what we have to do? Now, suppose I move like this. See here, the mass has come beneath the center of the probe. Now we move more towards this side. The mass has come towards the right side of the probe. So by moving the probe, we align the mass in such a way that it is closer to the needle. Whichever area from where we are putting the needle, let the mass be closer to it. There is one more thing which you have to keep in mind, and that I'll tell you with the mannequin again. Now you could make out that these masses, one is as I told you towards the right side, other one is towards the left side, and this thing applies if the probe is more or less in the transverse position. It may not be exactly transverse, it may be a little bit oblique also, fine, but it is more or less in the transverse position. Now what if the probe was in the longitudinal position? Of course it has to be placed properly as per the convention. Now it is placed longitudinally. Now once it is placed longitudinally, then this particular side represents superior, which means that the mass is beneath this area. So if you are putting the needle from here, it is going to be very close to the mass. In this case, the mass is here, which means it is closer to the inferior part here, close to inferior. So in this case, either we move the probe down so that this mass now comes in this position, that is a superior position, and then we can put the needle here, or we try to move from that side, from the inferior side. Now I have told you that the technique which is simpler for the newcomers is moving the needle in line with the axis of the probe, which is known as inline or in plane intervention. Now, suppose we are moving in line. For example, this is the axis of the probe, and in this line we are moving, this way we are moving, but we are not seeing the needle in full length. We are not getting a proper picture of the needle. What does it mean? Probably the two lines are not aligned properly. So in that case, what do? Tilt the probe little bit here and there so that the alignment is there. If the probe is kept like this, for example, and we are moving the needle this way and we are not getting it, again little bit here and there tilting so that a proper alignment is made. So that's all, and thank you so much.